folks?
Hey, Tim.
Hey, Tim.
How you doing?
Good. How you doing, Tim? Happy New Year.
Happy New Year. Glad the invite got updated. I think going forward, this should happen much quicker. I think the series has gotten transferred from David to Michelle, and then Michelle should make that a lot quicker.
Yeah, I think Michelle's on looking to see if she can be continuous with us, and I think she's pretty experienced with all this stuff, so it's good. Yep. Hey, Yeen, morning, and
Hey.
Bill, Dr. Cash, hey, Ben.
Hey, Stephen.
Let's give it another minute just for other folks to join. And while we're waiting, I'm just wondering if anyone can volunteer to be the note taker. So it's a pretty light responsibility.
Ethan,
yeah.
Can I nominate Ethan?
I'm comfortable with that if Ethan's comfortable with that.
Okay.
Thank you, Ethan. Just some light notes, and then at the end we just submit a PR back to the TSC repository to include the notes. I could do it myself, but sometimes I get involved in the discussions, and it's hard to do it when you're in the middle of it.
That's a good best practice for sure.
Okay, I think we can just get started. These are being recorded now, so I know that like there's some of these. I think Michelle has been able to recover some of the recordings, so these should be getting back onto YouTube again. So even if not everyone's here to attend, like we can also watch the YouTube videos and share those going forward. And I have this, but the code review and voting guidelines, I think I actually discussed that last time. So I'm not going to go over that again. I just wanted to, very quickly give a status on the TSC elections. Nominations ended yesterday. So Michelle will be kind of like starting the next steps, I think, by end of day today, sending out the Google form for voting for those who were nominated. So I think for those on the TSC, like just be on the lookout for that later today. So these are the seats that are vacated by me, Jameson, Ying, and Ben. Oh, okay, so that's the only update I had was basically on the TSC vote. Next up, I think we have two items on the agenda, one from Bill on TPCH and TPCDS plans, and then Pratikash on inactivity time. Actually, I would suggest we start with the inactivity time just because I imagine it's going to be quick, and then we can move on to the TPCH, which might have longer discussion.
Yeah, sure, Tim. So like if we are not waiting for anyone else, I can get started on that.
Yeah, go for it.
Okay, sure. So basically, like we do have a logic in place right now where we mark any open GitHub issue as stale after a time of 2 years. And I feel like 2 years is a quite long time, and that has resulted in a lot of GitHub issues which have been piled up in open state. So I feel maybe like there's a requirement to kind of reduce this inactivity time to maybe 6 months or less than that, because having too many GitHub issues in open state, that also gives kind of an impression that maybe the community is not very active. And so, I mean, basically not good from the community engagement point of view. So,
Yeah.
yeah, so I feel like we should probably reduce it, but I'm open to hearing others' thoughts on that.
So Pradesh, can you also give an idea, because you are a Hudi committer and other open source, can you give some idea of what other open source project you see that handle how they handle this?
Yeah, so basically like talking from Hudi community point of view. So in Hudi, we actually do this. Like if there is any like any GitHub issue which is open, and let's say the users are not kind of like basically there is no there is no activity on that GitHub issue for, let's say, maybe more than 1 month or 1.5 months. We feel that is a good enough time for any GitHub issue to be closed, because yeah, I mean 1 month is also too much. So yeah, so generally, I think the number of GitHub issues which will be open, they should be, I mean, in few hundreds only, like 100, 150 or 200. That should be the maximum number which should be getting reported on the repo page. So I think Presto right now is having around more than 750 or 800 open GitHub issues, which does not look good actually. Yeah, so I think so last week actually I did make an effort to kind of close a lot of open GitHub issues which were in open state, and there was no activity on them for a long period of time. So I think maybe like others can also volunteer to basically make an effort to reduce the number of GitHub issues, and definitely the inactivity time needs to be reduced there. So yeah.
Well, I think the fact Presto has many GitHub issues is because it's because it does have issues. So I don't think just blindly closing them would solve the problem. Actually, it may remove our attention to those problems that we think we should solve, but there's no time for that yet.
Yeah. So I guess like the question, Ying, is like, is the problem that the inactivity bot is 2 years, or is the problem that they're inactive?
Okay.
I think that there's an issue that we might want to take more active actions to triage those issues or try to fix them. Is that?
Yeah, exactly. So like, is the right approach to spend more time on triaging, or is the right approach to put more responsibility on the person who opened the issue and making it more quick to close them? And if they really need it, or if they really are interested in that issue being addressed, then they'll try to find someone who can own it from Slack, or, you know, pinging folks and, doing it that way.
I think it should be a combination of both, like definitely more efforts we can make for triaging the issues. And apart from that, yeah, I mean, the other point is also valid. I think Ying wanted to say something. Ying, please go forward. Yeah.
Hey, thanks. Well, if you're just talking about the period to make a GitHub issue from active to inactive, that I think your proposal makes sense. But I mean that we are very short of people resources to have those issues resolved. Actually, I'm not sure if triaging them constantly would help resolving them.
Okay, but I guess we agree on a high level that inactivity time can be reduced from 2 years, right?
Well, yeah, I'm okay with that. Not sure if others are good.
And that's the auto close time is the 2 years.
I think like we can measure these two things separately. The first is like the number of open issues, and like we can reduce the stale bot time to something smaller, and still not lose track of like the PR like issue turnaround time, which is like a separate thing, and that could be these can be measured independently. Probably issues should be triaged and looked at in a perfect world. And if we had, sort of like infinite amount of people to make the project better, ideally there would be like a full process where every issue has an owner, and like we come up with a plan, or at least someone takes a detailed look. But the way that you would kind of like measure, getting to that point would be, like what's like the first, how long does it take to get, a comment on an issue, like or a response? How long does it take it to close it if it hasn't been auto closed? You can still measure that even if you update the stale bot time to something much smaller. So like, I guess like what I'm saying is like we can deconflate those two things and decrease the stale bot time, but also, sort of like do a more thorough job of measuring like how well this community is responding to issues, and think about ways of improving that.
Sure. Yeah, I think we can categorize those GitHub issues and triage the bugs. So I mean, like put top priority on the bugs. It's like vlogs, we have like bugs, enhancements, and ideas and such. So bugs will be triaged soon, but enhancement might be remaining there for like years.
Yeah. Yeah, and yeah, that makes a lot of sense. Like some issues are really hard to turn around, but some are relatively easy. And then even within the bugs, it's a really great point. Like you would obviously want to prioritize the ones that are the most kind of like impactful to people, and the ones that aren't very impactful, you might not get to that for a while.
Mm-hmm.
So can we like basically come up with some way wherein, let's say, we can decide the inactivity time based on the label which is put on the GitHub issue?
Yeah, and that actually comes into my next comment, which is that actually the stale bot that we're using is it's very old, and I think it's actually not supported as it is now. I think this stale bot is, I think, like a very old version of what's called Probot. Some folks at Open Teams are actually building kind of like using a newer version of of Probot. So I think it's something that we can ask them to do, where if we have kind of like a set of labels that we expect, like we can maybe close it based on what the label is, and if there is no label, like maybe we could just close it. They're also doing some things like developing a workflow where the bot will kind of like come in and ask, kind of like ask for, what kind of tag does this belong to, so that, like we get consistent tagging and, that sort of thing. Someone has to kind of like manually add the tag still, but it at least kind of like brings consistency to how these are categorized. So I think that that's something that we can ask them to do, which is kind of like refine, this, like how it closes issues based on what kind of tag it's given. Would you want to like come up with like an idea or like some sort of proposal on, values depending on what kind of tag, or like, like what kind of tags might make sense, and then the values for those tags?
Yeah, I can explore around that probably, and I can raise a draft PR, and then maybe we can discuss, like, continue discussion over there.
Okay, yeah, we can also like talk on Slack about it. Maybe you, me,
Sure.
and Ying.
Yeah.
Sure. Okay. Mhm.
Cool. Sounds great.
All right, so the action item is probably actually to propose the tags and the stale or auto close policy associated with those tags and how we triage them.
Yeah.
Okay.
Cool. Okay, so if there's nothing else on the inactivity time, there's a great discussion, by the way. Thank you. We can move on to the TPCH and TPCDS plan analysis from Bill.
Yeah, hey, good morning, everyone.
Morning.
Hey, morning, Bill.
Show my screen.
Yeah, let me stop sharing.
You guys see now?
Yeah.
Okay, so I didn't really have a chance. I found out about this kind of late to put together a formal presentation, but I'm just going to basically show you, we've been running TPCH and TPCDS against brand X, right? And we've been analyzing what the issues are. Like we're analyzing where plan differences and differences in performance. And I'm just going to summarize those for you. And some fixes or some enhancements that we're actively working on at Ohana. So first, I'll give you the good news. So the good news is that everything in green on the right is Ohana Presto. Those are things that run faster. And for each of the 22 TPCH queries that actually run faster than Trino. Trino's on the left. So this is this is 1 terabyte. And so that, I guess this is the aggregate elapsed time, 8,619 seconds versus Trino. So that's good. Encouraged by those results. For those queries where we weren't, are not performing better, and I'll get to DS in just a minute. So we have kind of similar good news for DS. For those queries that didn't perform as well, or where we had plan differences, we tried to drill down and see what are the differences and how we can close the gap.
Very quickly, just wanted to ask, is it apples for apples, like similar hardware, similar number of workers, and that sort of thing?
No, no, yeah. Hey, Vivek, do you want to, I'm kind of joking. Yeah, we try to make it as apples as we could.
Cool.
Vivek, is Vivek with us? I'm not sure Vivek is. Yeah, but we did take we did take a lot of and I'm going to defer to some other folks as far as the setup for the benchmarks. But yeah, we did really take great pains to
George, can you make a comment?
Yes. So to answer Tim, your question, is it apple to apple? I would say we tried our best to do that as close as possible. We were running on the same instance type, and the both configuration was very close. We turned off like fragment result cache, we turned off the IO cache, and the bare metal, the instant type, the same. We used the same number of nodes, and deploying on the Trino ones that we also deploy on the HANA Cloud too. So we have made minor changes in terms of deployment scripts, so that it's compatible. But overall, we should say it's it is a apple to apple comparison
Cool.
from the performance point of view.
Cool, thank you.
Okay, so in doing this analysis, like what did we find? And I'm going to go through the issues if that would be helpful for you guys. I'll just go through these in order. So one thing we found that some of the session settings that we're proposing that these session settings be changed by default. And I think in the Ahana branch they are. And the first example of that is the default filter factor enabled, I believe is off by default. And that just means that you throw up your hands and say you can't estimate the selectivity, which seems like a bad idea. So turning that on just gives you a default filter factor of 0.9 for predicates if you don't know the stats, right? So turning that on, you know, is kind of critical. Otherwise, you're just flying blind. The second big issue, we had a lot of issues around dynamic filtering. And we know that this is an experimental, this is an experimental feature. We know that, but we wanted to leverage it if we could. But what we found is we had it on in Presto and we had it off. Sorry, and we had it on in Trino. But what we found is if we looked at the number of join orders using our nice tracing feature, we consider lot fewer join orders with dynamic filtering on, which made absolutely no sense. But when we looked at the implementation of dynamic filtering, we found out that it introduces an extra project operator. And these things kill, they kind of inhibit a lot of the join ordering capabilities in the reorder join logic. So what we did, and I believe this has been merged. The PR, this is the PR that we fix this. So we do this kind of in two phases. So we do it before we push predicates because dynamic filtering is part of the predicate pushing. We turn off dynamic filtering, we push all the predicates, we do join reordering, and then we turn it on and do predicate pushing again. So this fixes the issue with the join reordering, because otherwise you kind of cut the search space wherever that project gets inserted.
Okay, so then the project operator was inserted after the join reordering.
Yeah, after the join reordering logic.
All right.
And
So I'm curious. So did we try turn on and off dynamic filtering in Trino and see if did it make anything better for Trino?
Yes, we did. George.
Yes, we did, and they have actually a fix made that in something similar to what we have. That Bill just mentioned. That they also postponed building the dynamic filter after during the reorder joins, and the performance for them was actually good in our hand when we tested.
So their off is worse than their on.
Enable, yes.
But our difference is invisible, as you mentioned.
Yeah, it's on
Even
par.
after this fix.
Yes.
Even after this fix. So that's some execution issue then. And
Yeah,
I believe Parquet is the file format we tested.
Yes.
Mm-hmm.
Well, their channel is running Java 17. We are on Java 11, so I'm not sure if that would make a big difference. But
we are using the batch mode of the Parquet reader.
yes, we turned on that optimization. Yes.
Yeah, but it doesn't support filter push down.
No.
So everything was deferred into the filter operator. But I guess it's the same for Trino. So then I don't quite understand why they're seeing any improvement, but we're not.
Well, we're not actually really pursuing this because we know this is going to be something, hopefully that's going to be fixed in
yeah,
elements.
yeah, sure, I understand that. Just curious.
So actually something to extend to your question is that now Trino actually add support for supporting this cross-boundary dynamic filtering for hash join, where Presto only support broadcast join, right? Only for their local dynamic filtering. So I guess that will make it a little bit different too.
I see. Okay, so then it does apply to some of the TPCH queries that we needed. Okay, do you know which query was that?
There's a bunch of queries. I can add the query, the TPCH queries here.
Yeah. We should add the affected queries in each of the issues, but yeah, we can do that later.
Okay.
Okay, so let me see, were there other issues? Okay, and we also discovered, so this was not bucketed, not partition, non-partition, non-bucketed. And let's see, we also, another issue, we saw that if you enable grouped execution and it's applicable, it does not work if you have, well, dynamic filtering will not work with that. So those two won't work together. I don't recall the reason, but everything related to dynamic filtering, we're kind of deferring, we're kind of deferring and not actively pursuing right now on the planner side. So third issue, I kind of looked at this and said, hey, why don't we, so if you have a join predicate like A equals B, then you can infer that A can't be null and B can't be null because they would never survive. You can infer those as single table predicates. And I thought, hey, why don't we do that? And I proposed that, and then we discovered, hey, we already have that. Okay, so let's, but it's not enabled by default. Oops. Sorry about that.
Hey folks, Vivek here from Ahana. Bill, I have a quick comment on that one.
Okay.
I think going back to the configuration and whether they were apples to apples, right? I think one takeaway we found is that Presto has a bunch of these things which have been implemented, but they turned off by default, right? And it's kind of a iterative process where we realize that it actually has significant impact on performance, and which begs the question, we really need a process of enabling a bunch of these features which are off by default.
So can you give you a few more examples of this?
Well, the couple of things where one of them was what Bill was just saying, right? Optimize nulls and join is one. There is a default filter coefficient which helps with selectivity estimation, which is another. And there are a couple more which we stumbled across.
I can speak actually to both of those. I think the optimize nulls one, which I think we can, I think it might make sense to turn that on, but the reason it's not on is that if you don't have a lot of nulls, then you're adding the cost of doing the extra filter comparison. But I think that one, it might make sense to turn on. The default filter factor one is because we saw a lot of cases where, because the default filter factor is just kind of like, I mean, it's a kind of random. It's not very accurate, that we saw a lot of cases where it was creating bad plans, and our philosophy had been that it's sort of worse to take a user's query and make it bad than it is to not improve it.
But you're just getting lucky, right? I mean, if you're essentially guessing. I mean, either one is a guess.
I think
Either one is a guess, but one is a guess that's sort of controlled by the
Mhm.
Right. I think the
Yeah.
relying on the syntactic join order versus the cost-based optimizer's
So
choice, right?
that was sort of where why that was disabled. And originally, I think we didn't have that ability to disable it, and we chose to disable it so that we would reduce the negative effects, even though it means also if it means fewer improvements, and even if sort of the overall balance, it would have improved more queries than it hurt. I think we skewed that needed to be like a stronger, like a bigger improvement, in order if we're going to be changing the users.
Maybe your
Apply.
approach could be to kind of quantify situations or use cases where, I mean, this will help the broader community, right, to figure out exactly when and how to turn these on for particular use cases. Because I think in the benchmarks, we certainly see a significant improvement with turning this on. It's possible there are some use cases where it's negatively impacted, but
Yeah.
it would be useful to document all that and try to fix those issues if they exist.
Yeah. Talking about the cases where turning it on make things worse, it might make sense to look at them and fix them, but it requires tremendous effort. So
I mean, I think anytime that you're using the default filter factor, it's random, and it really depends on the shape of your data, as opposed to like improving in general the ability to make good estimates. Once you fall to the default filter factor, then it's going to vary a lot depending on the distribution of your data, the kind of filters that you have, that kind of thing. So that it gets a little trickier.
yeah, I mean, enumerating every situation is clearly impossible here, and unless we have dedicated person working on this, but we for sure we can submit issues where like where it should be better, but it's actually worse than.
So we have some long-term plans. I mean, this fits into one of our themes. Long-term is improving selectivity estimation, and this fits in that. And I think we have some kind of approaches to that we've been discussing that will really lead to us leapfrogging the competition. So it's not just playing catch up. This is really leapfrog stuff.
Yeah, I think if we can get to more cases where we don't even have to use the default filter factor because we have better selectivity estimation, then I think that would be a big improvement.
Yep. And so we also, I mean, this is great. I mean, we turn this on by default because this, yeah, and to your point, like other companies I've worked at, we found that we had a threshold, right? So if we looked and said, you know, I'm doing A equals B, and my stats say B has a significant number of nulls, and then I will, you know, I'll put this predicate on. If it's less than 10% or whatever, then and that was a configurable. So yeah, I mean, it's not going to help you obviously, right? If you don't have joins, and if you don't have nulls or have a very small number. And the other thing we noticed about this, it doesn't work for certain syntaxes. It works fine for some syntaxes, and combining ANSI and, you know, non-ANSI join syntax. It doesn't work in some cases. So we're pursuing fixing that.
Bill, did we but this didn't change the performance numbers, did it?
I don't remember the specific impact of this. I do think that it allows some outer joints to become inner joints, but I can't remember specific queries.
I see, because you know TPCH doesn't have nulls. But
True. Yes.
Yeah, enabling the stats help the left outer joint to be
So
transferred.
if I say T1 left outer join T2, right, and then inner join T3, and the join between T3 and T1, the inner joints between T3 and T1, you can turn that outer join into an inner join. And the way it's done in Presto is via this mechanism. So you say optimize nulls, and it figures out that once it adds those single table predicates, then it will turn that that outer join into an inner join. So that's when we felt like it's important to have this on.
Wait, how can you turn that outer join to an inner join? I don't.
Sorry. No, I'm sorry. If you're joining on T2, if you're joining T2, right? If you're T1 left join T2, and then you're joining to T3 on a predicate on T2, and it's T2 dot column equals, then you can turn it, right?
You're going to be filtering out all the nulls in that case.
And then the mechanism that it uses to do that is this, because it introduces, if that predicate were A equals B, then it introduces B is not null, and that turns the inner join to, the outer join into an inner join.
I see.
So that's why it's good to have on. And it's bad, it's bad if you don't have nulls, but okay. So this is feature. Vivek can talk more about this. If you can turn a semi-join into an inner join, that improves performance in some cases. TPC was the one, query 18 is the one most impacted. Vivek, did you want to add? I think this has been merged into open source.
That's correct. It was merged a couple months back. I think there were 2 queries in particular in TPCH which were improved as a result of this, and about 7 or 8 in DS.
Yep. Okay. And right. So let's see. The other one, I believe this is one. This is an issue with partial aggregation. And let's see, is this Trino has adaptive partial aggregation, right? So it doesn't look like the adaptive aggregation works very well. The adaptive partial aggregation works very well in Presto.
We don't have it.
Sorry?
Presto doesn't have it.
We don't have adaptive partial aggregation, right? So we insert this, we insert these partial aggregates in places where they're not helpful, I guess is what I'm saying.
Yeah, like I remember one of the questions I had was from the statistics and estimation, it does seem that having a partial aggregation doesn't reduce the cardinality, but Presto still has this partial aggregation in place.
Yep.
Right.
Yeah. So that's still open. I think that still requires some
yeah, and I checked my local HyperQuery runner, and I found the statistics for the partial aggregation was not available. I wasn't sure if in True that we see it differently. So if Anand is here, I don't know if we have any follow-ups on that.
I do not know.
So
And I don't.
Right. So we still had to go deeper and look at why the stats were not being correctly shown with the explain analyze, but I did run the actual stats and saw that we were getting the in the event listener stats that we were getting rolled up values which were pointing to the fact that partial aggregation done was not needed. So there is still some gaps. I can sync with you offline, Yang, on it.
Okay.
But
one thing I remember, sorry, go ahead.
Yeah.
Say one thing. Okay, one thing I remember about the sort of the cost decision relating to partial aggregate, when to add a partial aggregation, is that we're very conservative about it. That we only don't add it if the stats are like directly from a table scan and not if there's like some filters and stuff out of the way. So we can think about, do we need to be that conservative, or should it be more configurable about how conservative you want to be in that? But definitely adding adaptive partial aggregation like an operator side would make a big difference also.
So given that this is kind of a runtime optimization, right? I think we were kind of relying on the native worker to implement something like that. I was wondering if that was on the roadmap. The second point was, I think we have the HBO project, right, which is also potentially going to help with something like that for, to make decisions about whether partial aggregation is required or not.
Sure. Hey, Rebecca, you just mentioned the stats from the scan. Did you mean the runtime that we gather some like
What I mean is not runtime. I mean that when we decide whether to add partial aggregation, we default to adding it unless the stats say it's not going to be helpful, but we only do that if the stats have the is confident field set.
okay.
Which for the like regular CBO, that's only for stats that like come from the Metastore or like on the table scan. It's not going to be stats once you've done like a filter estimate or something. So it means that we're really not applying that optimizer in as many cases as it could be. With HBO, we always set that flag to confident if we're using historical stats. So that would make that optimization apply much more often if you're able to use the historical stats. But it might be worth thinking if we want to be, if we need to be quite as conservative in requiring confidence.
Yeah, agree. At least maybe introduce some session properties. So yeah.
Okay, I was going to say for Q17 too, I don't have a bullet point for this, but we did find that the decorrelation, we can improve the decorrelation algorithm for that. And I think that's going to improve the performance also, the way we do decorrelation. So we're going to open an issue and it will open that up for discussion, what we found. Let's see, like and not like, it's a performance issue. The predicate evaluation for those is much worse than in Trino, much worse in Presto than Trino. And it's just an algorithm thing. And I think that's going to be improved in Velox, right?
Hopefully, yes, but I don't think it hurts to just backport it from Trino. I think is the expression evaluation in CodeGen. That should be pretty well, I would say it's also orthogonal to the engine like Velox versus Presto as such.
Okay. Yeah, I mean, we can certainly look at doing that. Yeah. And also I think for some queries we saw that let's see, the in-list, I guess this is the in-list optimization. Trino has some performs the in-list processing better than let's see, was there anything else? This is a big you know, why are we faster? And a big reason is the Parquet reader with the batch read optimization. That's a big source of the advantage that Presto has. Okay, so pretty good news. Let me pull up let's see, I have some And this is in progress. So this is DS. These are the DS results.
Mhm.
And this is 100 gig. And let's see. So this is in, okay, this is the ratio of Presto to Trino. So so for about so we're concerned when it gets above, after talking with Ori, we kind of cut it off at 10% variability. So we're looking at all the plan differences. So first of all, we're analyzing the plan differences. And then we're focusing on queries where we're more than 10% or more
Mhm.
worse than Trino. And so what have we found? Some big issues that we found. Okay, so we need to re-examine these after the early out join, after we pick up the early out join code that I just mentioned, the implementing semi-join as inner join. We need to rerun these. So what are some other things that we found? We have found also issues with selectivity estimation, right? And to me, this is a fundamental issue. This is join selectivity. So what we've observed is if we have fact join dimension, in a lot of cases, the estimate for that is that there are more rows than are in the fact table. And okay, so that's impossible, right? I mean, that should never happen. It doesn't happen in Trino. So we drill down on that. So why does that not happen in Trino and it does happen in Presto? The reason that it happens in Presto, so they both have this kind of this fudge factor, right? We have this fudge factor. And in Trino, it's called join multi-clause independence factor. And so what this does when you're combining selectivities, if you have P1 and P2, it doesn't assume that they're completely independent, that there's some correlation. So you dial down the influence of the subsequent clauses, right? So P2 is going to have, it's not totally independent. There is some correlation. And so they have a different formula and it's configurable in Trino. In Presto, there's just this 0.9, right? You sort of, it's this fixed factor. And that's not, I mean, Trino's it's set so that they will actually not get more rows when you do fact join dimension than you have in fact. But in Presto, you will get more rows. So that's something we want to fix. And we want to fix that in the right way. We want to fix that by understanding keys. We want to understand primary keys. And the issue really comes up with multi-part foreign key, primary key relationships. It doesn't pop up if you just have FK1 equals PK1. It happens if you have FK1 equals PK1 and FK2 equals PK2. So what we want to understand is when join predicates, basically when they're many to one, that's what we want to know. And to do that, we're going to have to play, we're looking at how to do that. Like, how do you tell, how does someone who defines a table say, hey, this is a primary key, but you don't really have to enforce it, right? It's just like an informational constraint. And then we can leverage Dave Simmons, his key propagation or logical property propagation infrastructure to understand that this is a many to one join, right? So it can't be, you can't ever get more rows out than you have in the fact table. So that's cropped up a fair number of times. Another issue that's cropped up is this issue we noticed. So these are correlated subqueries, and they have aggregates. And so what you're trying to determine is when basically it's an aggregate correlated subquery. And what we noticed was Trino was able to turn this into an inner join, and Presto has to have a cross join on top of a left join. And if you know how the decorrelation code works in Presto, you know why that is. And I did some drilling down on this, and it's pretty easy to make a change. We're going to propose this as a change too. an issue. We're going to open an issue for this. It's possible to get it to convert to an inner join. And there's some other good things that happen when you convert this to an inner join and eliminate the cross join. You get filters pushed farther down the tree. And I won't go into more. That's probably more detail than you guys wanted to hear about that. But this applies like for Q41. I'm really anxious to see what the effect of this is because we're quite a bit worse. And this is the main issue. This is the main difference that we identified in these plans. And we're testing a fix. We're kind of testing that fix now. Let's see. These are different plan shapes. I'm not sure exactly why. Another, and I'll just list off some other issues that we found. Let's see. Maybe I've covered them all. Oh, there are some queries that have exist predicates, and I'm trying to find one here. I know Q10 is one. There's a bunch of other ones. They have it correlated exist, and rather than using left join for correlated exist, you can actually use inner join in some cases. And so we're also going to open an issue for that and propose. That's a relatively simple fix also, to not use left join and to use inner join. And that's good. And that segues into my next issue overall is reducing. So when you're able to convert left joins or outer joins to inner joins, that's good, right? Because we can reorder inner joins, but reorder joints does not work at all, right, with left joints or any kind of outer joints. Those are sort of optimization barriers. And so I think two things that I would propose going forward is, let's fix reorder joins so that works with outer joints, right? So we truly can explore the a bigger join space. And I think also handling, and it doesn't come up in the benchmarks, but customers certainly have large numbers of tables in the from clause. And I think we need a better story around not only the outer join, reordering with outer joins and inner joins, but we need a better story around what happens when I have a large number of tables, right? So what happens when someone throws 50 tables at this thing? And that's going to come up. I mean, we already see that, right? We already see that in one of our customers. 24 tables, I think we saw in one of their queries. Lots of outer joins interspersed with inner joins. And, we're not going to do a good job reordering those joins. Let's see. Yeah, I think that was. So anyway, we're rerunning some of this with, now that we're going to pick up Vivek's code and we're going to rerun this, and, we're just iterating on this. But overall, it's pretty good news because on a lot of these queries, we do, we're on par or perform, better.
Yeah, that's great, Bill. I just wonder, besides those differences with Trino, do you think there are other optimizations that can help these two benchmarks, tremendously?
Well, I'm really curious. I'm really curious, like if you had, a more robust or a more complete, version of reorder joins, I'm really curious about how that would help, right? Would that help? Would that hurt? Because I don't think Trino has a very robust, yeah. So that's a big one in my mind. I don't know the answer to it, but and also certainly things like if you just look at TPC-DS, having common sub-expression, being able to exploit common sub-expressions, there are tons of them, right? There are tons of them in DS.
Yes.
And, the way that I've seen that implemented and the way I've implemented in the past is really you need something like temp tables, right? You need to grab these common pieces and put them in temp tables, execute them once, and then you can reference them multiple times in the query. But I don't really think we can do that with the current, with our current infrastructure.
Yeah, I understand. But we talked about having using the current materialized views implementation for this.
Yes, you mentioned that, and I haven't followed up on that yet, Ying, but I will. Yeah, I'll try and take a look at that because that's a potentially, like I saw with Redshift / Parexel, I saw in some cases we got really dramatic, 95% reduction in some, run times when you can really do this right. So
yeah, that's right. So do we have a plan on that?
So from what I understand, that I believe that the materialized view work is deprioritized by Meta. So I don't exactly know how production ready that is. It would be useful to get a summary of what needs to be done, maybe to see that fully fleshed out.
Yeah,
Materialized views or materialized exchanges?
we
Materialized
don't.
views.
No, we don't. We don't have this in place, I believe.
Because materialized views isn't prioritized, but I think if you have just materialized exchanges, you basically have a temp table. We're thinking about that also similarly for when you have like a CTE to not have to recomplete it time it's used.
But that, in the other hand, would materialize everything, right? And
I'm
slow
saying
down.
not to materialize everything. I'm saying sort of take advantage of that infrastructure, but
okay.
not to do the whole materialized exchange plan, but just to take advantage of that infrastructure to materialize just a piece of it.
All right. So do we have to onboard like Presto on Spark, or is it embedded in Presto itself?
It's in Presto itself.
Is it a configuration property that we can turn on and look?
You can't currently say just materialize this piece. And we also don't currently have support for saying that these two different parts of the plan all both point to the same table, same, like a same CT. But I think you can reuse some of the infrastructure that's there for materialized exchanges. It requires changes, but I think that's sort of a direction to go in. And if you're interested in doing that, I would love to talk more about it because I think this is an interesting area.
Yeah, I think this will help TPCDS tremendously. And when I was asking if we have any plans on this, I mean like Vivek said, an actual item is to have this looked into. So if Rebecca, you can give some pointer in this, it'll be great. So maybe Bill, do you think someone of us can follow up?
Yeah, I think so we have, we kind of have 3 buckets, right? We have P0, so that's any customer issue, right? That's obviously high priority. P1 are the kind of the things that I've talked about here, right? That I've mentioned on these spreadsheet and on the Notion page. And then P2 is like, that's the leapfrog bucket. And I think this goes into the leapfrog bucket. So we have to come to some agreement, like internally, when are we done with the P1 issues, and when do we want to start moving on to the P2 issues? So this is a P2 issue, and I kind of guess we need to work that out with Dave. And
all right. So do you think the cardinality estimation belongs to P1 or P2?
I think the cardinality estimation should be in P1. I'm saying the joint selectivity estimation should be in
All right.
P1.
Okay, so then joint reordering is also in P1?
I
or
don't
P2?
know if I don't think the enhanced joint ordering fits in P1. I don't think it fits in P1.
All right, because several TPCH queries could be a lot better if we have the right joint order, right?
Oh, are you saying that we have the wrong joint order for some of them?
I think so. We talked about this a long time ago. There was one session when Ori visited and we analyzed some of the plans. George, do you recall that?
I think we were looking at Q18 and Q21, but I think after that we made some fixes, including the one that we talked about with the dynamic filter.
Mhm.
So some of them are actually fixed. In terms of TPCH, I think we are in a good shape right now. So that's why we move on to TPCDS.
You mean the joints doesn't have like a very obviously a very obvious drawbacks in reordering?
For TPCH, at least on the 1 terabyte, we are now seeing any issues now, right?
I believe with the default selectivity factor turned on, we get the right join orders.
Okay, all right.
See,
So
I still need to drill down on these guys, right? Like why do we have different joint orders for these cases? And we do have a few of these where we're different, and I want to drill down and see, like
okay,
why.
all right.
And if the answer is we need to be able to reorder, outer and inner joins better, then I guess it has to go in the P1 bucket. But yeah, I still need
mean,
to drill down on these guys.
I mean, if some of the P2 projects require less effort but can bring us really big improvement,
Yeah.
maybe we can prioritize them. Because investors won't care about if we exactly match Trino or not, right? Yeah, and also remember query 21 that we scan line items 3 times.
Right.
So how do you think we can solve that problem?
That's the reuse the hash table issue, right? That Ori, you can reuse the build side of the hash table, I believe. Yeah. So maybe that is something we should turn attention to. Yeah, we can discuss that and make that decision.
Yeah.
Sorry, Ying.
Oh, I'm just thinking what's in P1 and how much effort it needs to fix everything in P1.
I think we're Ananth and let's see, Ananth and Vivek are looking at the selectivity estimation for the multi-clause join predicates, and we're going to have a proposal on that pretty soon. Is that accurate, Ananth and Vivek? You guys are actively investigating.
Right. Yeah, I think we're kind of relying on.
Yeah, I'll be leaving this discussion, but feel free to take as much time as you need. Thanks, guys, for joining this TSC meeting. Thank you.
Yeah.
Thanks, Dave.
Oh, are we out of time?
I think the proposal is to rely on enhancing the metadata to use information about constraints to address the issue the right way, right? Instead of coming up with a hack to improve the selectivity and cost estimation in very particular cases.
I mean, we have our hack, Trino has their hack, but they're both just hacks, right? They're just, I mean, they're both just hacks. The right way to do it is just understand, the constraints and leverage those. And we already have the constraint infrastructure. We just don't really have a way for someone to tell us that right now. Like I create the
Okay.
table, right? And like, what is the primary key? Like I'm giving you a hint that this
Mhm.
guy, this combination of columns is unique. And
Yeah.
that's what Vivek and Ananth are looking into.
Okay.
Yeah, and the other fixes, like the ones for the decorrelation, those are relatively small, and we've already done some testing and prototyping for those.
Okay.
Okay, so go ahead.
Bill, did you find the dynamic filtering for hash joins could help TPCDS?
Do you guys remember, have we looked at that? We've turned it on and off, haven't we?
No, I think Presto doesn't, you're talking about across exchange boundaries, right?
Oh, well,
Yes. Yes.
So
Oh,
I think, so Presto doesn't have that, and I think Trino has published benchmarks which show significant improvement. on
yes,
TPS.
and I think, George, wasn't that a conclusion we came to about Trino with dynamic filtering, that it significantly helps them?
Yeah.
Mhm.
Yes.
Okay, so then that means supporting dynamic filtering for hash join, it's something we need to do, and maybe it belongs to P2, or actually this belongs to P1, right? Because Trino has it.
So given that it's a runtime thing again, we are kind of
Not a runtime thing. I think it does require the
I think we have a different
Right.
proposal. We have a different proposal which we are pursuing in Velox in conjunction with Ori for that problem.
Yeah, I understand, but it doesn't. Well, that is his solution is totally runtime. But I mean, if we really want to solve this right, and I believe his proposal doesn't work for all the situations. It does require a coordinator change somehow.
So, okay, so we as a group are not pursuing it, fixing dynamic filtering as part of our P1 bucket, because it seems like more of a runtime issue and it's going to be addressed in Velox. But if that's not the case, then we, if it's not going to be addressed in Velox, then we need to, see
Yeah.
what we can do, right?
I mean,
it's important.
even like in the execution side or runtime side, this should be considered. Yeah. I mean, I mean, our Velox team should be prioritizing this.
Yeah, that would, I mean, I was sort of assuming that was happening, but I don't know, because I'm not, I'm not as tightly involved.
Yeah.
But,
Yeah, I believe I think this may require both sides to work together.
okay. Yeah, that was all I had. Thank you, guys. I know we've run over, I guess, but George and Ananth, Vivek, anything else you guys wanted to add?
No, not particularly. I think that covers the benchmark analysis pretty well.
Yeah,
Okay.
I'm good on my side too. Thank you, Bill.
Yeah,
So
well, thank
Rebecca,
you guys. Yeah.
Rebecca, if you can give me some pointer about that materialized exchanges.
I think all the meta folks drop off already.
Oh, all right, okay.
Oh.
All right, so it's
Okay.
just our internal meeting now. All right, yeah, thank you so much, Bill.
Okay, yeah, well,
All
thank
right.
you guys. Okay.
Yeah, all right.
All right, bye.
Bye.